Okay, we've just finished the different graphs we can make. Now we're going to move into describing the data set with a single value. So it's gathering all this data together, and then we want to be able to describe it to someone quickly and easily with just one number. And we've got a couple different ways we can do that. So these three things I'm going to talk about today you are familiar with. They are your measures of central tendency. So what we have is one value that describes the whole data set. And we've got three ways to do this. The most common used way to describe a data set is to use the mean, or the average. Just like you being in high school, every class you take, you've got 9 weeks of grades, and the teacher's got to give you one letter grade, or one value to describe everything you did for 9 weeks. And most of us do an average. Granted, mine's a weighted average, which we're going to talk about today, but everybody else does pretty much a straightforward average. And if you remember, all an average is, remember the sigma from advanced algebra, you're going to add up all of your data values and then divide by how many you had. That's an average. Another measure of central tendency people use is called a median. And remember, median is the middle value in an ordered set. So for example, if we had 2, 4, 4, 7, 10, 15, and I asked for the median value, well, because they're in order, smallest to largest, there's only 6 numbers here, so the middle one in this case isn't listed here, but what I would have to do is average these two, the third and fourth values, to get the median. So if you have an odd numbered set of values, then it is the middle number. When it's an even numbered set, you've got to average. So the median here would be the average of 4 and 7, or 5.5. And then our third measure of central tendency is to give the mode value. And mode is just the data value that occurs most often. And this is the only measure of central tendency that we have for qualitative data. Remember, qualitative data are words. Well, you can't average words or find the middle word. So this is the only one, the only measure of central tendency for qualitative data. And one more vocabulary. What we're going to talk about are outliers. Now, an outlier is a data value that is far, not fair, far removed from the rest. Now, what's considered far removed, we're going to have a formula for that in another section, but for now it's going to be obvious when there's an outlier. And we're going to see what an outlier does to our three measures of central tendency. So our first example we're going to look at is right from the book. It's right here. We're going to be finding the mean, median, and mode of the following sample ages of a class. So this is a typical college class. There's 20 students in here, and they've got the ages listed of all the students in there. And you can see you've got a 65-year-old among this group of very young 20-year-olds. So this 65 being far removed from all the 20s would be considered an outlier. And we're going to see what happens to our mean, median, and mode. So, even though you can do means very easy on your calculator, you add them all up, the TI-83s were built to do these statistics rather quickly. So I'm going to show you some shortcuts. So, our first example. The sample ages from a college class. So we're going to leave the old guy in there. So we're going to go look at with the outlier, find the mean, the median, and the mode age. Well, if you look back, we'll get the mode out of the way, because the calculator does not find the mode. You've got to look and see which age occurs the most often. It looks like it's 20-year-old. 1, 2, 3, 4, 5, 6 of them. 4 of them. 3, yep. 4 of them. So the 20-year-old is the mode age. Most. Okay, for the mean, it would be you would add all 20 of them up and divide by 20. Well, like I said, the calculators were made to do this a little bit quicker. I took the time already to put all of those ages in list 1, and then I'm going to show you how you can get the calculator to do the adding and the dividing for you. If you quit and get out of your list, you're going to go under List, right here above Stat, so second list. I'm going to go over to Math, and if you look, there's mean and median right here. So I want the mean, so I'm going to press number 3. And I have to tell it which list I want it to look at. And our list numbers, like before, are here above the keys. Mine are in list 1, so in blue. So I'm going to go second, L1. And then there's the mean age. So it added all the numbers up in that list and divided by how many were there. So it's just a little bit quicker. And then the median, I can go right back into list again. So that's under second stat. Over to Math. The median age for list 1, 21.5. Because remember, it's averaging, because there were 20 people in that class, so it would average the 10th and the 11th ages. So yeah, we could have easily gotten that one. The average of 21 and 22 is 21.5. Okay. So now we want to see, well, what impact does that outlier have on these three measures of central tendency? So I'm going to eliminate the old person. So I'll go back into the list. Stat, edit. I'm going to go down to the 65-year-old. Delete that person. Now I'm going to recalculate the mean, the median, and the mode. So I'll go second list. Mean age for list 1, 21.57. Look at how much the mean dropped. The median, list, math, the median for list 1, is now 21. So not much, the bump of a half a year. And then the mode hasn't changed at all. So if you have an outlier, you can see that the mean gets impacted the most by an outlier. So the mean is impacted the most by an outlier. Because really, if you look at the ages, when you say the average age is 23.75, you really only have 3 people that are older than that age. Most of the people are way, way younger than that. So when you have an outlier, a mean is not a good measure of central tendency to use. Your median or your mean is a much better choice when you have an outlier. So either one of these would be good. If you throw out the outlier, then they're all pretty good. Alright, so that's the easy way to do an average on the calculator. Now into the tricky stuff, a weighted mean. I do weighted mean in here. You know, I weight the homework. You get 100% every day on homework, but I only weight homework 20% of your grade. Where quizzes and tests are weighted as 80% of your grade. So I do a weighted average. So this happens when all of the values are not weighted equally. So to do a weighted average, a weighted mean, here's what you have to do. You're going to sum up. You take each category average, multiply by its weight, and then divide by the sum of the weights. And most people set it up where their weights add up to 100%. So when you sum up the weights, 100% you're dividing by 1. It doesn't really come into play. But it's not very often that people don't have their weights add up to 100%. So this bottom part most times isn't used. But let's go through a stats class example. Several examples of weighted mean. So in stats, you get 20% of your overall grade is homework, and 80% of your grade, quizzes and tests. So, let's do a sample here. Homework, let's say you had 100, 100, 90, 85, and 100. Then quizzes and tests. So you had a 16 out of 21, 19 out of 20, and a 92 out of 100. What would your overall average be? So, if you look at our formula, first thing we need is the category average. So I have a homework category, and I've got 5 grades in here. They're all worth 100 points each. So I should say 100 out of 100, 100 out of 100, 90 out of 100, 85. So I need to average these up. So we're going to add up all 5 grades and divide by 5. So 100 plus 100 plus 90 plus 85 plus 100. That's all of them. Divide by 5. So I had a 95% average on homework. And now and I do total points here. So I had, and I'm going to do it all in one line. So I got 16 plus 19 plus 92 divided by a possible 21 plus 20 plus 100. So I've got a 90% there. So then my weighted average, I take my 95% times by the weight of 20%. And then I'm going to add my next category, which is quiz and test. I had a 90% average multiplied by 80%, but that's the category weight. The sum of my weights, I do have 100% there, so I'm dividing by 1. And then it's just a matter of cranking through that. So then 0.95 times 0.2 plus 0.9 times 0.8, 91% average overall, A minus. Okay, your class rank is also a weighted value because 25% of your class rank comes from your SAT score and 75% comes from your GPA. So we're going to look at a couple of situations and see how the class rank works. So Gladstone High School class rank. So only two categories, 25% SAT and 75% GPA. So let's look at two people. Student 1 has a GPA 3.98, SAT 1150. Student 2, now it's pretty, let's go 1250. Student 2, GPA 4.0, SAT 1200. Who's going to be ranked higher here, do you think? Well, let's go through the weighted average and find out. So, the weighted average here, formula says you take the category average and multiply by the weight. Well, I've got a GPA of 3.98. To turn that into an average, I got to divide by what it's out of. So that would be 3.98 out of a possible 4 for an average, multiply by its weight, and the weight for the GPA is 75%. Add on the next category, which is the SAT. They got a 1250. To turn that into an average, it's out of a possible 1600. So I need to turn the scores into averages and then multiply by the weight. For student 2, I'll do the same thing. 4.0 out of 4 times by 0.75. And then 1200 out of 1600 times 0.25. Let's see who's going to rank higher here. Okay. So, 3.98 divided by 4 times 0.75 plus 1250 divided by 1600 times 0.25. 0.9416. I don't know how far it'll have to go. That's going to be, okay, next person 4 divided by 4 is 1 times 0.75 is 0.75 plus 1200 divided by 1600 times 0.25. 0.9375. So the person with the higher SAT, lower GPA, is ranking above the 4.0 students. by just scoring 50 points higher on that SAT. Okay, let's try one more weighted average. Let's see, example 4. Let's say you take a college history class next year. Okay, and here's the way this professor is going to do their grades. Homework is going to count 10% of your overall grade. There's an essay, that's going to be 15%. The midterm exam is going to be 25%. There's a project for 35% of the grade. And the final exam is going to be 15% of the grade. Okay. Does this person make it to 100%? 25, 50, 85, yep, 100%. Okay, so our weights make 100%. Okay, so over the semester, the professor gave 3 homework assignments. You got a 100%, an 80%, and a 90%. Your essay, you got an 88%. Your midterm, you got a 95%. Your project, you got a 93%. And your final exam, because you didn't study so hard, 80%. So what will be your overall grade for the semester? Alright, well you can see these were all 1 grade apiece, so I don't have to do any averaging there, but my homework, I do need a homework average so that I can take the average and multiply by its weight. So, if I average up those 3 homeworks, 100 plus the 80 plus the 90 divided by 3, 90% average there. So remember, the formula is you take the average, multiply by the weight, and you add them all up. So, I'm going to have 0.90 times 0.10 for the first one, the homework. 0.88 times 0.15. 0.95 times 0.25. 0.93 times 0.35, and 0.80 times 0.15, and we're going to add all of those up. Divide by 1, which isn't necessary because my weight's set up to 100%, and that's as difficult as it is. So it's the category average times its weight, all added together. 0.9 times 0.1, 88 times 0.15, 0.95 times 0.25 times 0.35, 0.8 times 0.15, 0.905, so about a 91%. Oh, pretty good at getting that in that average. Okay, we're going to stop there for the day.